Matrix multiplication. Write down the definition. Multiplying a matrix by a real number, that real number is called a scalar.
The real number is called a scalar?
The real number that you multiply it by is the scalar. So in the example below, you have -3 times a 2 by 4 matrix, 15, -12, 10, 0, 20, -10, 7, 0, and all you do is multiply the scalar by each entry of the matrix, and you end up with this below. -45, 36, -30, 0, -60, 30, -21, 0. Got it?
But he not change it?
Yeah.
Okay,
Ready?
yes.
Alright, example 5a minus 3b. Capital letters are representing matrices. They tell you what matrix A is and what matrix B is, here and here. So all of this top right here is given to you. You have to simplify 5a minus 3b. 5 and the 3 are your scalars. So you're going to multiply your scalars and then subtract the two results. So when I multiply 5 by this matrix, 5 times 2, 3, -7, and 1, 4, 5 result in this matrix. 10, 15, -35, 5, 20, 25. Here, if you want to consider -3 as a scalar, you can do that. It would just make this an addition at the end. Okay? But we just left it as 3 is the scalar. So when I multiply 3 by each of those entries, I end up with 9, 0, 18, -3, 24, 6. Now I've got a subtraction problem. Remember, you can only add and subtract two matrices that are the same. You learned that last week. So what do we get here? What's 10 minus 9?
1.
1. 15 minus 0?
15.
15. -35 minus 18?
50.
-17.
No.
No,
-53?
Yeah.
Okay.
Yeah.
5 plus 3?
8.
8. 20 minus 24? -4. And 25 minus 6?
19.
19. Okay. Let's check our answer.
Wait. Oh, well.
What's wrong? That's what you should get. Ready?
Yep. Yeah.
Alright. Next example. We did a little bit of this last week, solving matrix equations. Now we just have a scalar involved. So you have 4 capital X means it's a matrix, plus 2 times 3, 4, -2, 1 equals 10, 0, 4, 2. Alright, so the first thing is to simplify, just like you were solving an equation. Simplify the left-hand side by multiplying 2. You get 6, 8, -4, 2. Okay, now we have what we had last week. How do I get this matrix to the other side?
Minus.
Subtract it from both sides. So we end up with, what's 10 minus 6?
4.
4. 0 minus 8.
-8.
-8. 10 minus a -4.
It's 4 minus.
Yeah, it's 4 minus 4.
Oh, okay. 4 minus -4 is what? 8.
Yeah.
And 2 minus 2?
0.
0. Alright, so we have 4x equals 4, -8, 8, 0. Alright, and to get rid of the 4, you can either divide everything by 4, but since we're talking about scalars, dividing by 4 is the same thing as multiplying by 1/4. So I make 1/4 my scalar on this side. So we're left with x over here. 1/4 of 4 is 1. 1/4 of -8 is -2. 1/4 of 8 is 2. 1/4 of 0 is 0. Question?
So you just, I'll get that last part.
Which to get rid of the 4?
Yeah.
Well, when you're solving any equation, if you have 4 times a variable, how do you get rid of that coefficient?
Divide.
Divide by 4. But
Why
dividing
not
by
just divide by switch it to multiply?
same thing, just because we were talking about scalars.
Okay.
Dividing by 4 is the same as multiplying by 1/4.
Okay.
Okay?
But wouldn't you wouldn't, so you're never gonna multiply that, you're always gonna divide?
We are multiplying. We're multiplying the 1/4 by 4. 1/4 of 4 is 1.
It's the same thing as dividing by 4.
Yeah, it's just like 4 divided by 4 is 1. Same thing. 4 divided by 4 and 4 times 1/4 are the same.
Okay. Oh, okay, alright.
Okay? Now, this might get it, this is a little challenging here. We're going to multiply 2 matrices. What type of matrices do I have here?
2 by 2.
2 by 2 and a 2 by 2. Now, write all of this down. In order to multiply 2 matrices, the number of columns of the first matrix must equal the number of rows of the second matrix. Write that down.
So they have to be the same kind.
No, they don't have to be the same type of matrix. Just the number of columns of the first must equal the number of rows of the second. After you get that down, we'll look at some examples.
Number of columns in the first.
Must equal the number of rows of the second.
So it
Now,
could
we
be
talked about adding and subtracting matrices. When you add and subtract matrices, they have to be exactly the same. You can only add a 2 by 3 to a 2 by 3. But here, as long as the number of columns of the first is equal to the number of the rows of the second, you can multiply. Okay, does everybody have the definition now?
So it could be 3 by 2 multiplied by 2 by 3.
Yes. Okay? Can I change the screen for a second?
Are you gonna change it
I'll
back?
come back to
Okay.
it. Alright, so let's just look at a type of matrix. Zach, you just said a 2 by 3?
3 by 2.
3 by 2, can you multiply a 3 by 2 and a 2 by 3?
Yeah.
Yes, because this number is representing the columns of the first, right? And this is the rows of the second. They're the same. So if you write out dimensions of a matrix side by side, all you do is compare the middle numbers. If those two are the same, then they can be multiplied. And your resulting matrix would be the outside numbers. So it would be a 3 by 3 would be your result. Okay? So if I had a 1 by 5, can I multiply that to a 5 by 8?
No.
Yes.
Yes.
Oh, yeah.
And what's your resulting matrix?
1 by 8.
1 by 8.
Yeah.
Okay?
Can we do 1?
Can you multiply a 1 by 5 and a 1 by 5?
No.
No. Because the number of columns of the first is not equal to the number of rows of the second. So it's best to list them out side by side and just compare the exact numbers.
Can you show how that works?
Yes, we're going to go back to the previous screen.
Can't you compare the outside numbers too?
Not to determine if they can be multiplied. The inside numbers determine if they can be multiplied.
Well, like if it was like 1 by 8 and then like 7 by 1.
Cannot be multiplied.
It has to be
No,
middle.
columns of the first, rows of the second must be the same. Okay, now let's go back. And then we know these can be multiplied, 2 by 2 and a 2 by 2. Now your resulting entries, see if you follow this pattern. R and C stands for row and column. To get the first entry, I'm going to use the row of the first and the column of the second. That should be a 2 there.
Where?
Column 1. No, that's fine. No, we're using all rows here and all columns here. So row 1 and column 1. Okay? Here I use row 1, column 2. Here I use row 2, column 1, and row 2, column 2. Alright, so see if you follow this pattern down here. Since I'm using the first row and matching it up with the first column, I do -1 times -3 plus 0 times 5 to get my first entry. And I should end up with +3. To get this entry, I have to use first row, second column. -1 pairs up with 3, 0 pairs up with 0. Add those together, you get -3. Everybody see the pattern? Alright, down here, I have to use row 2, column 1. 3 goes with -3, you get -9. -4 and 5 gives you -20, you end up with -29.
Is there an addition sign between both of those matrices?
Yes.
Oh, but you don't have it up there.
No. And to get the last one, I do 3 times 3 plus -4 times 0 to get +9.
But there's an addition sign between both of those matrices, right? Between-
Where?
between-
No, this is multiplication. We're multiplying matrices now.
Okay, but when you multiply one out of another matrix, then you have to add them together.
You had the results of each of them.
You always
Yeah, I didn't show that step up here, I showed it down here. Okay, this is just telling me to use row 1 and column 1 together.
Okay, so,
Okay.
but you always add.
Yes, always add right here at this step. Alright, now, let me show you on
Can
your calculator how to do this.
you not take it down real quick?
Sure. So get out your graphing calculator. You'll really want your calculator for this chapter. Alright, I'll come back to this Priyanka in a second.
I have it.
You good?
Yeah, I have it on now.
Alright, so in your calculator, you want, let me clear this. Okay, you want to go to second matrix. And you should get, if you've never used matrices before on your calculator, then you probably don't have anything right here. Okay, who does not have anything right here? Okay, that's fine. So you just have all the matrices. Now, go over, use the arrow button, go over to edit. Just go over to edit. We're going to edit the first matrix.
Do you press enter when you get
And
to
hit enter. And type in 2 enter 2 enter to get a 2 by 2 matrix. And then just type in all the entries. Make sure you use for the -1, make sure you use the negative button and not the minus. Here's the negative. So -1 enter, 0 enter, 3 enter, -4 enter. Then you're done with the first matrix.
How do you go back?
Are we ready to move on?
How you do
No.
that?
What's wrong?
This is so much
I don't
easier.
have an edit.
You have to.
No, it doesn't hold. Second matrix is in the.
Let me see.
So you go.
But there was no edit.
There
What
is.
did you do?
I- you just went over there.
But,
Chuck doesn't know how to do
No,
something.
you don't click second matrix, because your calculator already just has matrix right.
Okay. Alright, so once you get that one, just hit second matrix again. Go over to edit again. And do the same thing for matrix B. So go down, hit enter, and type in 2 enter, 2 enter. Then all your entries, -3, 3, 5, 0. Now you have your two matrices in. Okay?
-3, 3.
Then from that point, you have to get back to the blank screen. So hit second mode, which is quit, and you get a blank screen. Now to multiply the two matrices, hit second matrix 1, that's the first one, and second matrix 2, enter.
Spiffy.
Now, you won't get the same thing, or necessarily, let's see if we get the same
How do
thing
we
when we
get back to
multiply
the?
How you-
B times A,
Where's mode at?
right next to the second button.
Oh, okay.
So we do second mode.
Second matrix 2, and second matrix 1, so this would be B times A. Okay?
How can they possibly not be the same thing?
Because of those steps I showed you on the screen.
Can you redo this?
No,